Now, how are you going to remember the 17th group, which is otherwise called as the halogens? The 17th group is otherwise called as the halogens. Now, we all know naturally halogens comprises of fluorine, chlorine, bromine, iodine and astatine. Now, what is the way in which you can remember it? The 17th group, you can remember it with biryani. Okay, first class biryani in Austria. Is that easy to remember? First class biryani in Austria. F stands for fluorine, chlorine, biryani BR, iodine I and AT astatine. So fluorine, chlorine, bromine, iodine, astatine. So how do you say it? How do you remember it? First class biryani in Austria. And lastly, we come to the noble gases or the inert gases, which comprises of the 18th group with a configuration NS2NP6. Now you can remember it as hero never arrived, Kiran xeroxed from Rohan. I'll repeat, hero never arrived, Kiran xeroxed from Rohan. Hero, helium, neon, argon, helium comes here, helium, neon, argon, krypton, Kiran xeroxed from Rohan. So Kiran, Kr, xeroxed from Rohan, Rn. So by this way, by remembering these things, you can easily write down all the elements present in the P block. To give you a gist of what we studied in the introduction of the P block elements, we saw that in the periodic table, in the right corner of the periodic table, you have the P block elements in which the last electron enters the p orbital. And P block elements comprises of the elements from group 13 to group 18. The first members of the group 13 to 18 are boron, carbon, nitrogen, oxygen, fluorine and neon. The P block elements mainly consists of metals, non-metals as well as metalloids. All the elements are very important in our day-to-day life. Group 13 to 15 will be discussed in the second unit, whereas group 16 to 18 will be discussed in the third unit. Totally, in the P block elements, you have 35 elements present in our P block. Helium, though the last electron is only the s orbital and there are no p orbitals present in helium, but since helium is similar to neon, krypton and other inert gases, it comes under the category of noble gases. The general electronic configuration of all the P block elements will be NS2, NP 1 to 6. N stands for the number of electrons in the outermost shell. Now N stands for the number of the period or the period number. N stands for the period number. Period number 3, period number 4, 5 or 6 or 7. So that will be the period number. N stands for the period number. Now for each of the groups, if you know the first element's atomic number, you can calculate the atomic number of all the elements present in that particular family. Let's take group number 13, which is the boron family. Boron, you know, has got an atomic number represented as Z. Atomic number is 5. Now you know how to remember the elements present in the 13th group. BAGIT, bag it. So boron, aluminum, gallium, indium, thallium. First atomic number we all know, which is 5. Now you add 8 to it, you get the second element's atomic number. Aluminum's atomic number is 13. 5 plus 8 will be 13. Next, to the second element, add 18, which will be 31, which will be the atomic number of gallium. So to the third element, add 18, will be the atomic number of the fourth element, which is 49. Now to find out the atomic number of the last element here, add 32. So for all the other groups also, the same procedure is followed. 8, 18, 18, 32. You add it consecutively, you get the atomic numbers of the successive elements. In the P block, the elements present in the lower part are metals, while in the upper right part they are all non-metals. And the elements of group 13 having metallic character except the first element, boron, which is the metalloid. It has the properties intermediate between that of the metals as well as the non-metals. In group 14, you have silicon and germanium having its properties in between that of metals and non-metals. Similarly, all these are called as metalloids. The tendency of an element to form a cation by losing its electron, it's called as electropositive or metallic character exhibited by all these metals here. This character depends upon the ionization energy. Children, do you remember what is ionization energy? The minimum amount of energy which is required by a loosely bound electron by an isolated neutral gaseous atom or a molecule to remove the most loosely bound electron from it will be called as the ionization energy. This ionization energy for removing the first electron is called as the first ionization energy, and you can also have the second ionization energy. The ionization energy down the group decreases, whereas the metallic character increases down the group. So I'll repeat, the ionization energy decreases down the group, whereas metallic character increases. So as you go down here, you find the metallic character increasing. That is why carbon being a non-metal, here as you go down the group, lead becomes one of the most heaviest metal found. The various oxidation states of these groups are represented here for you. Being for the 13th group, you have +3 oxidation state. For the 18th group, the oxidation state is +8. The other observed oxidation states are also given to you here. Now when we look at this place here, you can remember the most stable oxidation state will be from the valency of this will be 2 less than the valency of the group due to inert pair effect. This is applicable only for the elements present in the lowermost period. And what is inert pair effect? Inert pair effect is produced due to the poor shielding effect of the D and the F electrons, which is overcome by the increased shielding effect of the additional P electrons. So that is all we are going to see for today. We will continue the other topics in the next class. Thank you, children.